This is a problem worked through for problem number 5 of lesson 3.3, drawing free body diagrams. Now, a free body diagram is simply a guideline, a diagram of the forces acting upon an object. Now, we represent the object in a free body diagram by drawing a dot. So that's what I've done here, and this dot represents the block in this problem. Now, if you remember the previous problem worked through, problem number 3, we did most of these situations, but we just identified the forces that were there. Now, if you remember correctly, we had a normal force that went upward, we had gravity that went downward, and then we had an applied force this way, pulling the block at a constant velocity to counteract the force of friction that went to the left. Now, when you draw a free body diagram, like I said, you start with the dot at the center, and then you simply draw all of the forces that apply to that object connected to this dot in the correct angles. But two things. One, the dot needs to be where the arrow starts and it points away from it. So you need to have it start at the dot, and then you need to have the head of the arrow pointing away. So in this case, we have 4 forces, one going up, one going down, one going to the left, and one going to the right. So we had, finally, once you draw all the forces in the correct orientation, we label them. The normal force went up, the applied force goes to the right, gravity goes downward, and the force of friction goes to the left. So when a block accelerates down an incline, gravity went straight down, normal went perpendicular to the surface, and we had a small force of friction going up the slope. So here we draw our dot. Once again, the force of gravity comes straight down. Normal force is perpendicular to the inclined surface, so it's going to come up roughly at that angle. Doesn't have to be exact, but it has to be close enough. So that's our normal force. And then, as we see, the force of friction is actually at a right angle to the normal force. So we come down, come out, and there's the force of friction. Now for part E, the block is held in equilibrium as it hangs from 2 ropes. So gravity is still going to pull it down, but now we have 2 ropes, and they are going to provide a force of tension for the block. So we draw our dot, always draw the dot first. Now, doing the diagrams, you can do the arrows first and then come back and label them, right? That part doesn't really matter, but this is force of tension, this is force of tension, and this is force of gravity. Now, if you want to be really specific, you could come back and say this is tension 1 and this is tension 2, but that's not really necessary. For part G, we have a wall and a surface, and they're holding this block in place. So we have gravity coming down. The surface that the block is on is going to provide a normal force coming up this direction. But this wall is also going to provide a normal force. So it is holding the block up and preventing it from sliding down the hill, but it's passive. It's not actively doing anything. So this is a passive normal force going this way. So our diagram, once again, will look like normal force, perpendicular will be another normal force. This one's coming from the wall, that one's coming from the surface underneath, and gravity is going to go straight down. So force of gravity, and once again, you could do normal force 1, normal force 2. On this one, I'm just going to list them as normal force. You could even do surface and wall, right? But that's up to you. Finally, we have a block that's held in equilibrium by a rope and an incline. So we have gravity that comes down. We have a normal force that comes up perpendicular from the surface. But now we have this rope, which the tension is a direct connection between the object and the environment. And the direction of that force is always from the object to the environment. So that means that it's going that direction. And this is a force of tension. So we have our object, gravity comes down, normal force comes up, and tension goes off this direction. And that's how you draw free body diagrams.